Good morning, good afternoon, good evening, good whatever it is where you are today. I'm Ali Almagasu, and this is the Thanksgiving week edition of Cloud Unfiltered. You actually are probably not hearing this on Thanksgiving week because we're recording it during Thanksgiving week. And we have such a fancy and complicated post-production process that this won't be out till after you've already fattened yourself up on stuffing and turkey and sweet potatoes and all the goodies. So that's what's going on here in real time. Today we're really excited because we've got, the OpenStack Summit just happened. And we've got somebody from one of the marquee projects that was kind of launched at this past summit. It's been getting a lot of press, a lot of attention. His name is Glenn Seiler. He is from Wind River Systems, where he is VP of Product Management. Welcome, Glenn.
Thank you, Ali. It's a pleasure to be here.
Pete, good morning. Always a pleasure to be interviewing with you.
Hey, Ali, glad to be back as always. And like you said, this is not only a marquee project, but it's a really interesting, I think the next wave of technology that a lot of people are going to be paying attention to is going to be centered around the topic that we've got for this episode and an upcoming episode we've got here as well. So excited to talk about this.
Yeah, so the project that we're referring to is called StarlingX, for those of you who haven't heard about it. Glenn, why don't you go ahead and give me a high-level summary first of what StarlingX is and what it's intended to achieve?
Sure. So StarlingX is essentially a full-featured open source cloud stack designed specifically for the distributed edge. So it's a software stack that basically encompasses all of the technology components necessary for a cloud infrastructure targeted for many of the broad use cases for the edge.
That sounds really ambitious. And,
Yes.
and yeah, it sounds like it could be a lot of things. So if you're someone who's already using any number of the OpenStack components, of the core components, even some of the less core components, what's the need? What drove the need for this?
Okay, great question. So really there's a set of capabilities that didn't really exist in what I would call the enterprise cloud solutions. And these are things, such as high resiliency, low latency, configuration management, software management, performance management, things of that nature that really didn't exist in more traditional enterprise cloud stacks. And as you start to evolve the data center cloud or enterprise cloud down to the edge, then things like very low latency, very small footprint, high resiliency, things of that nature are required. And so what StarlingX brings to the table that's perhaps new and not existing in previous enterprise cloud solutions are these services. And one other point I think is important to note, StarlingX evolved out of the telco industry, out of an NFV, network functions virtualization stack, where some of these high availability and reliability and software management requirements are required in telco. And StarlingX has taken that core capability and created a broader edge software stack that can really be targeted or used by many different industries. It's not specifically for telco. We have organizations in the industrial 4.0 market, in aerospace and defense, as well as automotive, that are all looking for this kind of solution.
Interesting. Hey, Pete, I know you had some questions about the specific either features or components of StarlingX.
Yeah, I do. So you've got a nice article out there describing sort of what StarlingX is, and you've got a nice block diagram that shows what some of the services are. But I guess before
Right.
we dig into that, let me ask you at a higher level, because I think industry-wide we're pretty muddied on this. What in your definition of edge as opposed to IoT? Because those two things tend to get thrown together in different ways. And for a lot of people, including myself, it's hard to know where does one leave off and where does the other end.
Well, great question. And as you already know, every person you ask is probably going to have a slightly different answer. So one of the things that I like to do, first of all, is talk about what the edge is not. And it's not the device. And so by device, I'm talking about the drone, the robotic arm, the cell phone, things of that nature, the car itself, although that is a little blurry. But I don't really consider those the edge. Now, what I do consider the edge in telco, it's often referred to as the central office, all the way down to the base station itself. In industrial, it could be the on-premise, for factory automation. It could be in high-density venues such as stadiums and shopping malls. That would be considered as well. And there's also a discussion about far edge versus near edge. And I kind of consider the near edge more of the aggregation point. So it could be the central office, things of that nature. Whereas, again, the far edge is really all the way out to where the device is. But one classification or definition that I particularly like is defining it not by location, but by latency. Because the edge is really anywhere where the communication between the device and the compute that is managing and communicating with that device, the latency requirements are anywhere from 20 to maybe a maximum of 50 milliseconds or less.
Okay.
And so that really kind of defines the edge.
So in that definition then, and contrasting that with IoT use cases tend to focus on gathering data from remote places and then shipping that data back to some central processing point, whereas I think as you're defining edge, that processing point is the thing that's distributed and is defined by that 20 to 50 millisecond response time that you just mentioned. Is that close?
Yes, that's correct. I also associate IoT, with the devices themselves, which the edge, I really don't. I kind of, the device and the edge is where the separation is. With IoT, as you rightly indicated, typically there's an IoT gateway or something that connects to the devices, and then the IoT gateway might then send that data up all the way to a data center or a public cloud or something of that nature. And I think historically or previously, the concept of an edge cloud wasn't really included in the typical IoT architecture.
Sure.
It was device to device gateway, and then up to the cloud.
Sure.
And I think what's happening now with edge and the edge clouds is that they're coming down from the gateway and starting to converge with these IoT devices. And
okay.
Yeah.
Well, I think we've got a good academic definition of what we mean by edge versus IoT. Now, you mentioned a couple different verticals that are active in this edge phenomenon. Can you talk about a couple of use cases before we get into how your platform potentially helps solve those use cases?
Certainly. I already mentioned the telco use case, which is kind of the most obvious or the one that I think is probably the most common use case, and that is primarily around radio access networks today, mobile access computing, mobile access edge computing, those types of use cases. Pretty common, and so we're seeing a lot of organizations that are pushing compute all the way down to the base station
So like having like a mini cabinet at like a cell phone tower base you're talking about.
Absolutely, that's becoming quite common. And then, providing services, whether it's video services, caching services, which is probably one of the most prominent use cases, I think, today, because that actually drives revenue.
Sure.
But in other markets, healthcare, for example, is one that I like to discuss, and I have a couple of clients that are evaluating StarlingX for edge use cases there. So you can envision a large hospital complex where you might need an edge cloud that would have redundancy, have a lot of compute power, and then there might be smaller edge servers at each one of the principal divisions. So there might be an edge server in the patient care, might be an edge server in the X-ray lab, and each one of those might be collecting, managing data from different devices. Could be MRI machines, other types of X-ray machines. Could be monitoring patient care, where the patients are actually hospitalized. So that's one example of healthcare. And then you could scale that down to smaller, perhaps outpatient centers that don't need as much power. They don't perhaps have inpatient care, but they're still doing MRIs and things like that. So that's another example in healthcare. And then we have a lot of industrial applications as well, primarily on-premise, factory automation, those types of use cases. What we're seeing, I was just going to say, what we're seeing in industrial is that the digital transformation, where companies are taking older PLCs and distributed control systems, virtualizing those, and starting to automate the factories and the processing centers.
Okay, so that 20 to 50 millisecond lead time that you're talking about, that kind of defines what edge is, then becomes very obvious in the context of those use cases, because you want quick turnaround time for all those things, certainly.
Exactly.
Okay, that makes complete sense. So then let's move on to, now we've kind of defined like the academia and the use cases. So what are the limiting factors that people are experiencing when they try to do these deployments now that StarlingX can help them solve?
Certainly. So again, one of the things is just scalability. And most clouds today, enterprise data center clouds, are really designed for very large control planes. Oftentimes, OpenStack services might be, each OpenStack service, whether it's Glance or Nova or Neutron, may actually be on its own server.
Sure.
That's certainly the old kind of traditional way. So one of the things that we've done in StarlingX is we've hyper converged all these services, control plane services, down to a single server, so that for those use cases that require it, you can actually combine a control plane, a data plane, or a workload compute, as well as storage, into a single server running, say, a Xeon D on 8 cores or something. And so you get a pretty small footprint.
Mm-hmm.
So scalability is certainly one of the key attributes that StarlingX is bringing. Now, some of the other things are what we call the StarlingX services. We fondly refer to that as the flock. And it's things
I like that.
such as fault management, and monitoring for threshold alerts, monitoring for failures, logging and alerting for those failures. Things such as software management, the ability to upgrade the entire infrastructure stack, whether it's the Linux kernel or the OpenStack services themselves. So software management, host management, failover, the ability, if you have multiple servers, to actually fail over services from one one server to another, or compute node to another, and things of that nature, which we've been able to take those services and move them all the way down to the edge in as little as a single server, if that's what's required.
Okay. So if you take if you go to StarlingX.io and you go to look at the blog, you've got a really nice initial blog entry that describes some of these things that you just described verbally. And there's a really nice block diagram that mentions those 5 flock services that you just mentioned: the config management, fault management, host management, service management, and software management. And then there's a nice list of open source building blocks that you guys are using underneath the hood to provide all those.
Exactly.
So functionally, how does this look to me as, let's talk about a couple of different personas here. So if I'm like the IT ops person, do these things just plug into my existing Horizon UI, or what does this look like to me?
So we provide a Horizon UI, and we've made a few enhancements or plugins to Horizon to support things such as our node management and configuration management, inventory management, that type of thing.
Okay.
But for the most part, yes, it is essentially Horizon with some enhancements that we have brought to the open source community through StarlingX.
Okay. And is that, I mean, you guys could have done this as a wholly separate open source project, but instead you made the choice to sort of piggyback on top of OpenStack. Was that part of why, so you didn't have to reinvent that wheel when it came to the management UI, or what all went into that choice to be part of OpenStack as opposed to standalone? Oh,
great question. So first of all, StarlingX uses a lot of OpenStack services. Right, so the control plane for StarlingX is based on core OpenStack services, Neutron, Nova, in particular, as well as Glance and Keystone. There's quite an exhaustive list, and in a lot of cases, we as we develop StarlingX would have to make plugins to Neutron, for example. We would have to upstream some patches to Nova or some of the other services. And because there was such a tight affinity or relationship with OpenStack, it really made sense to partner with the OpenStack community to drive a whole solution forward. The OpenStack community has been extremely supportive of this initiative and this effort, and it's really been a very pleasant experience.
Cool. So is the intent then to keep the same cadence as the broader OpenStack releases, so to have some kind of major contribution every 6 months or so?
Well, actually, right now we're moving at a little bit faster cadence than OpenStack. Our plan is to do a release of StarlingX about every 4 months rather than 6 months for OpenStack. Now that might change over time, but initially we wanted to get the first release of StarlingX out quickly. And really what we did with the first release is what I call infrastructure. We put together the build environment, the build tools, the test tools, making it available to the open source community. And that was, so it was really just the bring up. And now we have a set of pretty ambitious goals for release 2. Specifically around things like containerizing OpenStack and providing a complete container platform. Another initiative or ambition that we have is to continue to create a complete distributed edge cloud based on the concept of OpenStack regions. So we want to get the first releases of these new capabilities out to the market so that they can be tested and people can start using them in proof of concepts and things of that nature.
Okay.
Yeah. So right now it's a 4-month cadence.
Nice. Okay. Well, that's that's interesting that you're taking a slightly different cadence. But I can certainly see why you'd want to build on top of OpenStack then if you're going to reuse a bunch of those existing services.
Yes.
Well, so let's talk through another use case here and eventually get to the developer perspective. So we kind of already talked about the IT ops perspective a little bit, but suppose I've got like a fast food chain and I've got 10,000 locations in North America, and I might have a small HyperFlex box in each one of my locations that presumably my IT ops person might use the StarlingX host management services to connect to some central governing authority where one central IT ops person can see all those things.
Right.
So I guess my first question then is, okay, so to that IT ops person, does each one of those locations that has a hyperconverged box in it, does each one of those show up as a separate, given what you were just talking about, does that each one show up as a separate OpenStack region, or do I just see like is that just a sea of compute nodes on top of which I let the software decide where my next VM or where my next container is going to spin up?
Sure. So quickly, those would be what we call compute nodes.
Okay.
And so there could be, literally thousands of those, at least in theory, thousands of those compute
Sure.
nodes.
10,000 in my example, one at each physical location, let's say.
Yes. So the concept of what we're doing with StarlingX is that we have the control plane services and the compute node services. They can be hyper converged together into a single box, or they can be geographically distributed. As we evolve towards this distributed edge cloud that I mentioned, which is one of the sub-projects and is an initiative that is one of our prime initiatives for the future releases. Okay. As we move towards this distributed edge cloud, we would regionalize the control plane services, and so that only the compute node, the workloads with as little control plane services as needed would be at these 10,000 locations. Okay. And then those would be managed at the regional control plane. And there would be a single pane of glass using Horizon that would be able to to provision, to manage the thousands of different workloads. And it could be even more hierarchical, so you could potentially have multiple of these regional controllers with then yet another even further centralized data center, mini data center. So it could be a hierarchy of 2 layers or potentially even 3 layers. But the key important concept here is that the regional controller would have most of the control plane services. So at the regional level, you would have centralized storage. You would be able to manage backups, manage upgrades, provision out new software from these regional centers. You would have some federated security, based on Keystone, which is one of the technologies that the industry is really trying to work on right now. Federating Keystone across this distributed edge for security. But most of the services would be control plane services would be managed regionally. So you would be able to monitor for faults and then take appropriate action, from this regional control plane.
Okay. Well, then, so you mentioned the software management. So let's move up the OSI stack a little bit here, and let's talk about this from layer 7 and above, from the developer perspective. So in my use case that I mentioned before, suppose I've got 10,000 fast food locations, and I'd like these local nodes to handle the mobile ordering for each of my individual locations. So what does that look like from a developer perspective to get that order taking and management software on that local node? And then what happens with like HADR kind of situations where like if the physical hardware goes down in one location, at what point in the system is it, whose responsibility is it to make sure that that ordering system spins up on the next closest node in, I hesitate to call it a cluster, but in this grouping of hosts that we have, is that something that Starlink's going to handle on itself automatically, or is that on the layer 7 app developer to figure out the failover on that?
Okay. So I think there might be a combination there. So first of all, it depends at the local store that you mentioned. If there is just the single server, and that single server fails,
right,
then there really would not be a capability to migrate the service over to another server at the same store. So if there is a requirement for a high availability type of application, then what is recommended is that you would have what we call a duplex servers. You could have 2 low-cost servers at this store, and then the StarlingX, the centralized regional control plane services, would be able to monitor and recognize a fault, a failure in the server, and then either migrate the application directly from the one server to the other, or if it's a hard failure, the server is completely down, then re-provision a copy of that workload, probably through a container, to the other server, so that you can get up and running immediately at that location.
So it would be so it's not. I'm reading too much into this to think that it's going to do failover across multiple locations, but it sounds like it's got the hooks in there for you to be able to do failover within a single location.
Yeah. So I guess that it kind of depends, like you said, on where it's at layer 7 or layer. We certainly have the capability to do failover at the lower layers, at what I call the infrastructure layer.
Okay.
Now, if you have, we can also monitor applications, and so that would be at layer 6 or 7. And if there's just an application failure on these local nodes, then you can re-provision or restart the application. We can identify the fact that the application's failed. So, there's, without getting into the age-old debate of infrastructure HA failover versus application HA failover, the short answer is StarlingX can accommodate both, because oftentimes you need both.
Sure.
An infrastructure HA as well as application HA.
Sure.
And so what StarlingX really provides is the infrastructure level HA. And then if the application HA is required, then that would be done at layer 7. But we certainly have APIs. We have heartbeat APIs, other checkpointing APIs and things of that nature that enable application failover if that's required in the application.
Okay, thanks for explaining that. That makes it a lot clearer. Well, let me conclude my portion of this before I turn it back over to Ali. What's coming up on the roadmap for you guys?
Well, we're doing some pretty exciting things. Right now, StarlingX, when it was initially designed, was primarily a V-oriented infrastructure platform.
Okay.
And in our next release, what we're doing is moving to a full Kubernetes-based container platform. And what we are doing, what our plans are, is to containerize the OpenStack services, so that if an organization wants to deploy VMs, then we can deploy OpenStack services in a container and run the VM as a container on those services. Now, what this does is it allows us to really provide a much smaller footprint, because we'll have just a container-based environment without the hypervisor and so on, and this will allow us to further reduce the footprint, but it will also allow us to support both containers and VMs in a single architecture. And then, depending on whether the organization wants to use VMs or containers, you can deploy both as what we call equal citizens. So we don't have an architecture that's strictly just containers at the expense of VMs, and vice versa. And still be able to use all of these StarlingX services that I mentioned, whether the workload is a container-based workload or a VM-based workload.
And is that going to be Kubernetes-based, Swarm-based? What's going to be?
It will be Kubernetes.
Okay.
Kubernetes-based.
And going back to the use case we talked about before, so would that Kubernetes cluster span multiple hosts within a location, or would it span multiple locations, given the use case conversation we just had?
So really, it could be either. You could have multiple locations that would all be part of a single Kubernetes cluster managed at the regional the regional location as I described, or you could have smaller Kubernetes clusters locally. Really just kind of depends on the use case. We envision primarily the former, that you would have smaller workload-based servers locally, and then managed by a more central Kubernetes cluster. That's really how we envision most use cases or workloads being.
Okay, great. Good questions, Pete. Thank you for diving in there and really exploring those use cases. Those were great questions.
Thanks.
So as we wrap up, Glenn, when I introduced you in the beginning, I introduced where you work from and what your role is there, but we didn't talk about what's your role at Starling. Are you on the technical steering committee? Are you the PTL? What is your role there?
So it's really more of a marketing and strategy and liaison role.
Excellent.
So what I do is I work with other community organizations as well as my customer base to bring in requirements to the StarlingX community.
How many folks would you say are working on this project right now?
Oh, goodness. We're probably around 100 right now. We started out primarily as a joint initiative between Intel and Wind River. And we just filled out our technical steering committee with members from Huawei, Ericsson, some other companies, Interdynamics, as well as 99 Cloud. And we're starting to get developers from a pretty broad set of organizations and geographies. So it's pretty exciting, and I'd say it's grown pretty quickly just in the last month or two. So we probably are well over 100 developers now.
And how long were you working on it before it was launched? And I'll put that in quotes at the recent Berlin Summit.
So actually, we started working on this back in December of last year, and Intel and Wind River primarily, and we put the initial seed code into the open source community in May of this year, and made some initial announcements at OpenStack in Vancouver in May. But it was, very, it literally had just put it into the open source community a week or so before the OpenStack Summit. And it was really just, we were kind of introducing it. And then from May to October of this year, we put out the first release 1.0 of StarlingX, which we made available in late October, and then did the formal launch of StarlingX at OpenStack in Berlin.
All right, so you guys been working on this for a while. Sounds like it's got a solid base going, and it sounds like it has some exciting capabilities that are really very tightly aligned with what I'm hearing about, the need for better edge everything, better cloud on the edge, better networking on the edge, better everything. So that's exciting. At the beginning of the show, the other thing I neglected to do, we'd like to start with, today we're going to finish with, is I'd like to ask you how you got into tech, because we have a lot of folks who are early in career that listen to this show, or more specifically, our college students thinking about, a career in tech. And we'd like to explore people's different paths to this career. Sure.
Well, so I started in my career actually in college in computer science, and specifically with a master's degree in operating systems theory. And I'd like to think that I'm probably one of the few people that actually got a master's degree in a technology and then stayed with that my whole career for almost 35 years. Through companies such as Texas Instruments, where I started my career, and I started as a trainer and then as a field analyst, but then moved into product management pretty early in my career in the mid-'80s. And ever since that time, I have been doing product management for operating system products, which is what I actually got my degree for. And so I went through the transition from proprietary to open source back in the 90s, working for a small software company called Santa Cruz Operation, then moving to BSDI, Monta Vista, and ultimately Wind River, managing operating systems and predominantly open source based operating systems. And so that's led me, gradually over my career from being a product manager to managing a team to becoming VP of product.
Cool. Well, thank you for sharing that. And more importantly, thank you for being on the show today and helping all of us understand, what StarlingX is and does. I know that as many people as were at the Berlin Summit, there's many, many more that could not attend, and so didn't really get to sit in those seats and hear firsthand all about this project. So we thank you for joining us and explaining it. We hope you'll come back and join us in the future as this project matures and adds new features.
Well, that would be my pleasure. I think it's going to be a very exciting 6 months for StarlingX as we gear towards our release 2.
Great. All right, well, that's going to be our show for today. Thank you so much again, Glenn. Thank you, Pete. It's always a pleasure to chat with you, my friend.
All right, see you next time.
All right.
Thank you.
Bye-bye.
Bye.